All right, so the following recent dramatic drop of 500 points in the Dow Jones Industrial Average stock market. A poll conducted from the Associated Press found that 92% of those polled said they were said that a year from now their family financial situations would be as good as it is today or better. There's a lot of psychology in terms of it. Which of the following describes the number 92? So 92% is of those polled. So that's from the sample, which means it is a statistic. 92% is the sample statistic. It is the sample proportion. What is the distribution of values taken by the statistic of all possible samples of the same size from the population called? That is the sampling distribution of that statistic. Suppose you take a random sample of size 25 from a population with mean 120, standard deviation of 15. Your sample has a mean of 115, standard deviation 13.8. Which of the following has a mean of 120 and a standard deviation of 3? So the population standard deviation was 25. Was 15. 15 divided by the square root of 25 is 15 divided by 5, which is 3. That is the sampling distribution of the sample mean. That's how that 3 came from. In order to use the formula, standard deviation of the sampling distribution of sample means equals standard deviation of the population divided by the square root of n. Which of the following conditions must be met? So 1 or 2 must be met, and 3 must be met to be able to do that. So the answer is D. Either 1 or 2. That is the nearly normal condition. The sample, you need to have a sufficiently large sample, or the population is already normal. 5 was a tricky one, and I was debating back and forth why some of the answers are there, but it's based strictly on the central limit theorem. The central limit theorem says that regardless of the shape of the distribution of the population, if you take a sufficiently large sample, then the sampling distribution will be approximately normal. The answer is, in fact, A. I know you're saying probably the main thing that, which I was getting is, well, where's the part about being independent or random? And it's the assumed. The central limit theorem doesn't actually say that. The central limit theorem is that nearly normal condition. So when I call it the nearly normal condition, it's really the central limit theorem that's at work right there. So a simple random sample of 1,000 Americans found that 62% were satisfied with the service provided from the dealer that they bought their car. A simple random sample of 1,000 Canadians found 59% were satisfied with the service. The sampling variability associated with these statistics is, so they're both 1,000, right? So the sampling variability will not be exactly the same because 162, and I actually said this one wrong to somebody yesterday. The answer here is that, let me double check, I want to make sure. I had originally read this question as what would the sampling distribution be in comparison to the sample or to the population distribution, and that was a false statement. Yeah, so the answer here is actually B, because the first one is going to be 0.62 divided by the square root of 1,000, and the other one is going to be 0.59 divided by the square root of 1,000. So they're actually going to be very close to each other. They're not the same, but they're going to be pretty close to each other because the sample size is such a large sample. If the sample size was only like 10, they would probably be very different. We would say get square root of 10. A student investigating study habits as a simple random sample of 16 students, which is not very large. how many minutes they spent on the English homework of the previous night. So